Welcome to Brain Vision.
In this problem, we want to figure out the revolutions per minute to achieve the desired gravitational pull in a space station. So to do this, I'm going to write this form for the radial acceleration in terms of the period. It's equal to 4 pi squared times r over t squared. In this case, 1 over t is equal to the number of revolutions per second. And so if I solve this for t, I get that t is equal to 2 pi times square root of r over g. And this is really the key equation in this problem. We're given r is 800 meters, and in part A, we want the acceleration to be equal to g, which is how I solve for this. I said a rad is equal to g, and then I solve for t to get this. And so g in this case is 9.8, because we want to simulate Earth's gravity. And so when we plug that in, I get that t is equal to 56.77 seconds, which means that 1 over t is equal to 0.076 revolutions per second. Remember, the interpretation of 1 over t is revolutions per second. And so we need to convert this into revolutions per minute, because that's what the problem is asking. And so to do that, I'm going to have seconds on the top to cancel these seconds, and then minutes on the bottom. 1 minute is 60 seconds. So really, I just need to take this number and multiply it by 60 to get my desired answer. Whenever I do that, I get that it's 1.057 revolutions per minute. And that's the answer to part A. In part B, we're still going to use this formula, except for instead of originally substituting a rad is equal to g, I'm going to substitute a rad is equal to g star, where now g star isn't necessarily 9.8. It's whatever gravity we want to simulate. And so since we want to simulate Mars' gravity in part B, I'm going to substitute, I think it's 3.7. Yeah, 3.7 is the gravity on Mars. I'm going to substitute 3.7 in for this g here and do the same process. And so just to outline some steps, in this case, g star is equal to 3.7. Doing the same exact calculation now, I get that 1 over t is equal to 0.01082. And this is in revolutions per second. And then now I need to multiply by 60 to convert it into revolutions per minute. When I do that, I get 0.649 revolutions per minute. And those are the two speeds that we have to spin this thing at in order to simulate the gravity on Earth and on Mars. So this is the answer to part B here.